Yo, it's Pap here. Have you ever wondered why or how the Nintendo Switch tells you to log in once? You log in and it doesn't have you log in anymore. You just log in once and then that's it, right? You turn it off, turn it on, and you're in. It's a little device. But if I got a new device, I just log in again. I don't need to make a new account. You ever wondered how that happens? No? Me neither. Who asked that? Who would ask that question? Well, now that I have your attention, let me tell you a story. The year was 2007. I could see it clear as day. iPhone just came out. It didn't have a flash, so I thought it was the most dumb invention in the world because it had no flash to the camera. Who does that? Like, come on, who does that? Sidekick was losing its popularity. You remember those little flip Sidekick phones? Yeah. Facebook. It's been out for about 3 years, starting to get popular. You know, people making Facebook accounts. I never had one in 2007. I think mine's came later. But that's besides the fact. Facebook just announced new Facebook for mobile. Web browsers supporting mobile utilizing HTML5 and a REST API. Yep, that same API that allows you to log in to this switch and creates that session token and stores that session token so you can remain logged into your Nintendo Switch. You know, the answer to that question that nobody asked. So, mobile's out, world's happy, technology's at an all-time high, and then it comes crashing down. Users realize that Facebook newsfeed was relatively slow. What did Facebook do about it? Well, this is the story of GraphQL. GraphQL was made because a REST API was becoming too slow for mobile. And quite frankly, HTML5 didn't work for mobile either. So what is GraphQL? Glad you didn't ask. GraphQL is a specification on how to talk to APIs. It's that simple. It's a powerful tool. It allows you to push many buttons in one query versus a REST API pushing one button per query. Right? It's very useful. Take my word for it. It's useful. Now that you know a little bit of the history behind how GraphQL came to be, with this mobile compatibility for websites exploding and being extremely popular with the new releases of these smartphones that weren't really that smart if you think about it, but we call them smartphones. Now you know a little bit about that. Let's dive into a few more things to help get you familiar with GraphQL. And when you end this video today, you, my friend, will be, well, you'll be you. You'll still be yourself, but I mean you'll be yourself with a little more knowledge. So maybe I can say you're a better version of yourself. Yeah, you're a better version of yourself. That's what you'll be. So we're going to go through more of GraphQL, right? Understanding what GraphQL is. I'm going to compare GraphQL with a REST API just so that you can see the differences, show the advantages of the differences. We're going to get to see a lab of how GraphQL queries and returns data, how that's different from a REST API. We'll go through some common GraphQL misconfigurations, configurations, and also use cases. So if you haven't noticed, you can use GraphQL as a standalone, but you can also use something called the GraphQL gateway, which is basically taking GraphQL and bolting it on top of a REST API, which then allows you to use RESTful services along with GraphQL and is good for migrating from a REST API to GraphQL. Okay, after all that, we're going to put on our hoods and our black hats because, yep, we're going to start looking at how to exploit these GraphQL APIs. Stay tuned. I got something for you. I told you, I got something for you. I got you. Let's jump right in. Okay, so before we jump into the architecture of GraphQL, we need to understand a RESTful API. Well, we need to understand APIs at an overview, but I'm not going to get into too many details around the API. There's another video coming for that. I got you. However, we can get into the inner workings of a RESTful API service so that we can see how GraphQL differs from it. And then we get to see some of the advantages that GraphQL has by comparing the two. And also you'll get to see some of the issues that might arise with GraphQL, but there are ways to get around that. We'll see it. We'll see it. Really quickly, there are three notable types of APIs. There's SOAP-based that use XML format, and those went extinct with the dinosaurs. Kidding. SOAP is still used, it's just not as common anymore. The most common API used today is RESTful. RESTful APIs that have this parameter value type of format, as we can see in this example. Actually, this ID is a parameter and value would be 1, as we can see in this example. And then RESTful usually returns some kind of response based on the data that was available for the backend. So in this case, the response is JSON format, but it's not limited to JSON. You can have multiple different types of formats that are sent in a response for a RESTful API service. Okay, let's jump into this API and let's see how it works. I'm going to give 3 scenarios for you to understand how the API works, but then the last scenario is going to show you an issue that arises with RESTful API services. And this issue happens to be the very same issue that was happening with Facebook when they decided to migrate to a new service, which eventually became GraphQL. All right, so before we jump in, I'm going to just explain what is happening here, and then we'll jump into the 3 examples that I mentioned. So API, very standard API usage. As we can see here, we have the application making a request to the API and the API responding back to the application. Now, this API gets that information from some kind of data store, database, whatever you want to call it. But there's some kind of system that has information stored that the API needs to talk to in order to retrieve that information. Once that information is retrieved, it sends it back to the application, and the application is generally directly tied with the user's device. What I mean by that is a user's web browser views the application, and the application is talking back and forth with the API so that the view in a browser is consistent with the information that should be viewed. A lot to say there, but just remember, this is DB, database, and this is, I guess we can call this the browser. Let me redo this here, right? It looks weird. Looks like a tongue, actually. Okay, let's write BR for browser. So DB browser, and that's the flow here. Okay, so example 1 with the RESTful API service. Example 1 is I want to view someone else's profile on Facebook. We're using Facebook because why not? It just fits the theme. I want to view someone's profile, but the Facebook service only should return the user's name and maybe a profile picture, but we're not going to include that in the example. We'll say it should only return the name for this example. So what happens is my browser sends a GET request. So API takes multiple requests. A GET request is reserved for reading information, viewing, querying information. It is not used to change information. It can be used, but that's not standard. I don't recommend setting up an API to use GET requests to change information. It's not standard at all. So in this case, we'll say we're just trying to read information. We're reading information from this path. Now, this would be a website path, so example.com could be an example, example.com/API/user. So this path, we're querying the API, we're telling the API, we want to get a user. Now this question mark is basically giving us more context here, and we're saying we want the user with the ID that is equal to 1. So of course the application sends a request to the API. The API is like, got it, I got your request. Let me check the database and see if there's any entry with that. Oh look, the database returned, right? It checks this database goes back and returns to the API. Yes, there is a user with the ID of 1, and this table, we have that user's name. That user's name is Pap. So, checks out, API gets what it needs, it sends that data back to the application, and now the application sends that to my browser, and I can view the Facebook profile of Bob Smith. He's a cool guy. if you haven't noticed. Okay, example 1 works very well. All right, let's look at example 2 and let's see how that works. Example 2 would be, okay, I want to update my own street address. I don't want to access any other information but my street address. In fact, I don't even want to update my street address. I just want to verify that it actually equals what it should equal. So I'm not even going to use a post request. I'm going to use a GET request just to query my own address. So as always, in the Facebook profile, let's say I go to my account settings. The application needs to now send a request to the API. So we call that request 2 here. That request is going to get example.com. It's going to query the API for an address. Then it's going to say, oh, I need to give some context as to which address I want. So it'll say, I want the address where ID is equal to 1 in the database. Sure, sends it over to the API. API queries that database. Database responds with, yep, the ID is equal to 1. I'm seeing a table that has the street address, 123 Batman Way, and the city, Gotham. From Gotham, boys. So the API sends a request back to the application saying, hey, I got that information. It does not include the ID this time. If you notice that. The ID is, you can set it up to include the ID if you want. It doesn't always have to. In this case, we imagine that there is some kind of foreign key that's attached with this table. That goes into databases. We'll cover that in a later course, but just know that this data here has some relation to the ID in this table here. Just know that. So you don't need to re-specify the ID because it's being pulled from the ID in a different table. Okay, so it sends a request back, and then that request goes to this user's browser, and now I can view and verify my address. Again, works really well. Actually, it works a little too well. Let's look at example 3, the example that Facebook ran into, and let's see if we can identify the issue here. So let's erase, we'll erase these two here, these arrows and things like that. So example 3 is we want to view our accounts page, and that accounts page needs to include all the information about us. Now, for the sake of this example, we'll say the information included is our address and name, but know that there are more things like date of birth, email, and other things that could be included when we're looking at our own accounts page. So let's see how the API handles that request. So the API knows that there are multiple tables, right? One table is to get the name, the other table is to get the address. So what the API has to do is first make a GET request, and we'll call that request 1 to the API, and it's going to query the user with the ID of 1. Sends that request. Of course, the API does its magic, responds, okay, yeah, we do have the ID of 1, name's Pap, sends that back. API sends it up to the application. Nice. Now we have one request, the name, but we still have to get the address. So request 2, the API sends request 2 to the API again and said, okay, I have the name. Now I just need the address. API queries the database, comes back and says, here's the address, 123 Batman Way, Gotham City. API says, thanks, puts it back up to the application. Done. Did you see an issue there? Let's go over this again. The API had to make 2 requests in order to get an address and a name for this account section. Let's say we added more parameters to this. Let's say the API needs to get date of birth and the API needs to get email whenever you click on the account section. Well, now every request you make, so every request will be 1, right? 1 request automatically gets multiplied by 4. So every time you go to your accounts page, in this case, you're making 4 requests per person, or per device, I should say. Per browser, maybe that might be a better term. Per browser tab. You get the point. Okay, now, what if there are 1 million users out of, I don't know, we'll say out of a billion. 1 million decides to just make a request to look at their account information page. Well, the number of requests is multiplied by 4, and we're talking about 4 million. You see how that gets a little slow after a while if you're just multiplying by 4? What if you added more parameters? Instead of 4 requests, now you have to make 10 requests. 20, 50, 100. The point is, a RESTful API has to make a single request to get different pieces of data in order to present it back in one view. And that process takes time once you start talking about higher numbers and a lot more complexity. Now, a question you might ask is, why don't you just store all of the data into one view and the API just returns everything at once? That way, you don't have to make multiple requests and all the data is in one view. Remember example 1, right? That's the answer to your question. Example 1 says, I wanted to see the profile of someone else. Now, if I made a request to see the profile of someone else and the API returns all this information back to me, well, now I can see that person's date of birth, their email, their address, their phone number, any information about them that should not be revealed from just looking at their profile. So we have information disclosure, a security issue there. So in order to protect the data of people, this data needs to be separated into different tables, databases, data stores, however you want to separate it. There needs to be some relation from this data to all the other data tables that we see. And that relation is then used while the API is querying that information so that it can be returned individually, but then seen as one view. So we can't just store everything in one database here because the API returns everything that it has from those tables, and we don't want that. So that's an issue, and Facebook realized that issue, especially when the mobile, it wasn't a mobile app, it was the browser for mobile. So it was literally mobile support for Facebook.com. The mobile app did come out later, but we're talking about the slowness of mobile support for Facebook.com, which ultimately led to GraphQL 2012. This complex, beautiful specimen. Now, let's look at how GraphQL differs from RESTful API and what makes it so useful and obtain the limitations that the RESTful API could not obtain. So, same format. We have the application making requests to the API. This is the DB here. API, of course, talks to this DB, and the application talks to the user's browser. Boom. Same exact format. Now, one thing you notice is there's only one HTTP request, one response. There's a post for GraphQL, and even the path is different. It's not API user param value. It's literally GraphQL. Then you have your type, and you have some information down here. We're going to go over all this. All right, so let's start at the top. Post request, very common for GraphQL. Actually, GraphQL uses GET requests very seldomly. I think there's like one type of query that uses a GET request. Other than that, you're generally going to see post requests for GraphQL. Now, /GraphQL is the default path for GraphQL API. It can be changed, but it's usually standard to keep it at GraphQL just to provide context as to what it is. But just know, most of the time, you're going to see a post request to GraphQL. Okay, so query. What is this? So GraphQL has two different types. Well, they have a few more types, but two very unique types. Those are query and mutation. I'm not going to go into all the other details at this time. We're going to keep this high level. So query is for reading data from the GraphQL API, and mutation is to change information from that GraphQL API. So think of querying as a GET request, and think of mutation as maybe a post, put request, update, delete request, one of those kind of requests. So that's the two structures of GraphQL. So you send a post request, and then you specify what you want to do with that request. In this case, we're querying that request. So here's where it gets unique, because in GraphQL, you're saying, I want to query only the user that has the ID equal to 1. So you're already telling the API, only look into the information that has the ID of 1 assigned to it. That's it. Don't look at anything else. Now, you're telling it what you want from that user, right? You want the ID, you want the name, and you want the address. But you only want specific things in the address. Those things are street and city. So it sends it over to the GraphQL API, and the GraphQL API understands, okay, I'm only going to look at the ID 1 from the database. I'm going to grab exactly what you asked for, which is a feature of GraphQL, which is the ID, the name, and the address, 123 Batman Way, and got them. Then it sends that information back, of course, and the GraphQL API will send that up to the application, and eventually you'll see it. Now, what happens if I change my query and say, I don't want to see the street address anymore? This is the beauty of GraphQL, because it only sends you data that you ask for. nothing more, nothing less. So if you only want to see the street address, you send that to GraphQL. Now, this database, let's say this is all one table. So, you have a table, and this table contains all of your data, just like we thought the REST API could do. Now, GraphQL says, okay, let me talk to this database. It says you only want the ID, check. You want the name, we have the name, PAP. You want the address, in the address you don't want the street, so we actually don't need this street. You don't want it. So, no. And you do want the city, check. It sends that back to you, boom. And the beauty of it is it's doing that in one request. You don't need a separate request, you're not multiplying by 4. Every time you can look at your account information, grab only what you need, one request. Look at a profile, grab just the name, one request. Whatever you want, look at a news feed, one request. That's the beauty of GraphQL. It's a lot faster than a RESTful service when we're dealing with data that needs to be separated. In fact, you don't need to separate the data anymore because GraphQL has a feature that will grab only what it needs to grab based on the request sent. Now, as I said this, you're probably wondering, well, what about that security issue? And if you're not thinking about that security issue, let's put on our security hats. There lies a security issue with putting data into one database. Let me give you an example or a scenario. You want to query someone's Facebook profile. So you tell GraphQL that I want to get the name, and this will be your browser. I want to get the name and the ID from my browser. Send it to the application, and the application sends it over to the API. The API says, cool, I have the name. You don't need the street address or anything, so I'll return the ID and the name, but I'm really just returning the name. I'm not going to return the ID. Send that over to the application, and then eventually, it goes to back to your browser. Now, that works really well. We see that. But what if we say, now I want to view the user's profile, right? And we change our request, our HTTP request, to say, I don't want to just get the name. I also want the address of the profile that has its address hidden. Now it's all in one data store, all the data. You send the request. Theoretically, GraphQL will say, oh, well, you do want the information, right? Grab that information, and it's going to send it back. Go to the application, and now you can see the user's address. What if it was phone number, email address, date of birth? If that's in a database, you send a request to GraphQL. As long as you know the parameter and structure, it sends it back to you, and you have information. So technically, it's security by obscurity. You only secure until the hacker finds out the parameters used to get that information. Well, that's a big security vulnerability, isn't it? Luckily, there is a way to protect against that with GraphQL. There are ways to set security boundaries or controls to make sure that GraphQL, when it's looking at when it receives a response from the application, the API can say, you don't really have permission to look at this stuff. There are ways to set that. We're going to look at some of that stuff. Actually, we're going to look at that in just a few seconds. We're going to be looking at a demo of GraphQL. We're going to get to see the different types of queries, how mutation works, how the general query works, the structure, because GraphQL does look like JSON, but they're actually strings when you get down to the root of it. It doesn't really use a JSON format like we think it uses, so you'll get to see some of that. And then we'll get to see some of the misconfigurations with GraphQL. So native GraphQL, right, that doesn't have these security controls baked into it, and how to actually add these security controls to it. And then we'll last but not least put on our hacking hats, and we're going to figure out how to hack these GraphQL APIs. Now, when we go and figure out how to hack these GraphQL APIs, we're going to be focusing on things like what questions to ask, or we'll ask for things like, what do we look for with GraphQL APIs? It is more valuable to ask questions, to figure out what to look for, to figure out how to think as a hacker, than it is to load up a tool and run the tool. You need to understand how the technology works under the hood, and you need to understand what the different configurations are, and how to abuse those configurations, because that's what makes you the best of the best. Let's dive in. Okay, now that we know how GraphQL differs from a RESTful API, and we know a little bit about GraphQL, let's talk about some of the common misconfigurations, and I'll explain a little bit about these configurations, and then we'll get into the juicy stuff where we get to look at some exploits. It's going to be a little different. I'll go through my mindset when I'm going through these things. I think in cybersecurity, it's common for us to just jump to tools and use tools, and I want to step away from that. I want to get into the mind, the critical thinking part of it, and how we as cybersecurity professionals, enthusiasts, champions, whatever you want to call yourself, how we can obtain that critical thinking mindset that enables us to be some of the best hackers that there are out there. All right, so we'll get into that after we go over these misconfigurations, but let's dive into this. So for GraphQL, there are a few misconfigurations. One of the notable things in GraphQL for you to remember is that natively, there is no security built in. What I mean is unbox GraphQL, out of box, no security whatsoever. So when we set up GraphQL, we really need to make sure that we're configuring it correctly and that we're using the proper security controls, as well as doing things like disabling introspection and other things. So let's go over these misconfigurations. The first one is leaving introspection enabled. So what is introspection? It's widely used. In fact, you're going to see it when we start looking at the exploitation of GraphQL. But for now, just think of introspection as the tool within GraphQL that allows you to query information about the GraphQL schema. So what I mean by that is think of it as similar to like an API documentation or API document that basically explains how the API works. Introspection pretty much explains how GraphQL set up, the schema, and the available queries that might be within a specific GraphQL instance. So that's introspection. It is not recommended to leave that enabled. You can probably guess why. An attacker will most likely use introspection, and I'll show you how that can be done, to query for available queries, and that will allow the attacker to map out the GraphQL instance, but also look for other pieces of juicy information to get things like information disclosures, to do things like denial of service, to do things like server-side request forgery, and there's a plethora of different attacks that can be launched once you understand how the GraphQL is set up and all the queries that are available. Another thing to keep in mind is that it is very common for companies to disable introspection in production, but leave it enabled in like a test environment, a dev environment. So you want to make sure that you're disabling introspection in test, dev, and production, not just one environment, because oftentimes these environments mimic each other. And then if an attacker has access to introspection in a dev environment, there's a good chance that they'll be able to migrate over to prod, and a lot of those same queries would work. Good chance of that. Okay, another misconfiguration is enabling GET requests in GraphQL for sensitive queries. Now, as I mentioned before, GraphQL uses post requests primarily. However, there are cases where GET request is used for a query. Now, it is not recommended to use GET requests to query for sensitive information, but every once in a while, it's okay to use a GET request. So what do I mean by that? Not to use a GET request. Well, as I mentioned, GraphQL grabs information in one request, and you only get what you ask for. So if your data includes sensitive information and a GET request is sent, all it takes is for someone to send a GET request to what they ask for, which is that sensitive information, and it's retrieved. Now, if you aren't familiar with how GET request works, once it's retrieved by the browser, it's usually stored in browser history. If you're using a proxy, it's stored in proxy. If you're using, like some kind of caching service, it's stored in that caching service. It might be stored in logs. There's a bunch of places where it could be stored. So if you're going to query for sensitive information, you really don't want that information to be stored anywhere, on a client. But also you don't want that information to be stored on a server, because that GET request might have, the full path there might be stored in server logs as someone requests it. Just refresh. Get request usually has a full query in a URL, whereas like post request, for example, has the query in a body or data is posted into. So get request for non-sensitive information, completely fine. If you're just query name ID equals 1, it's just a name. If you're not worried about that, yeah, no issue. However, if you're querying for session tokens, passwords, you definitely want to use post for GraphQL. In fact, I would argue that using post for GraphQL should be used in pretty much all cases, and get request should not be used, but also get request should be disabled. Okay, not limiting nested queries. That is a big misconfiguration for GraphQL, or query depth as we can call it. So what are nested queries? I call it query inception, right? Queryception. A nested query is a query within a query, within a query, within a query, and you can just keep going. For example, if I had, let's say I had query A, right? And inside A, we have a value of B. And then inside B, we bring it right back up to A, and then right up to A, we bring it right down to B, and so on and so forth. You kind of get the point. If I keep going, well, there's a possibility that I can make this nested query long enough that by the time I actually run it, it would crash the GraphQL API, denial of service. So that's why you don't want to leave nested queries. It makes the API vulnerable to denial of service due to the unlimited recursion, I guess you can call it, right? Another misconfiguration, failed access controls. So this is one of the biggest misconfigurations of GraphQL. Sometimes people might think disabling introspection saves people from accessing information that they shouldn't have access to because the queries are not visible to that person. But there are ways to still query for information without introspection. So it is important to have access control because you don't want a user to be able to read information for other users, or even worse, to be able to read information from an administrator or anything. So self-explanatory, and access control should be added to GraphQL APIs. They do not come added out of the box. Failure to implement rate limiting. Now, it's another one, especially for login forms. So if you're using GraphQL for login forms, you want to add rate limiting. You don't want to allow a user to be able to brute force a username and a password. You want to allow rate limiting to stop that. And that is a misconfiguration if rate limiting is not set. Okay, last but not least, of course, these are just common. There are still more configurations out there for GraphQL. In fact, there's a plethora of them that, devs will most likely need to read through. And if you're thinking about configuring your own GraphQL API, I recommend that you read through it as well. But last but not least, failure to limit query cost. So the idea behind this is GraphQL has a cost associated with each query. Now that cost can be limited. There is a way to build a limit so you can have cost equal to, 3,000, for example, cost equal to 100. Without that limit, you're basically allowing an attacker to run a recursion script, or by hand, whatever they want. I don't know what they want to do. Most likely to be some kind of script to keep querying the GraphQL API endlessly over hundreds and hundreds of requests, which would drive the cost to ridiculous prices. So if you're a big corporation and you're using GraphQL and it incorporates some kind of cost per query, you want to make sure that you're limiting the cost per query, and you want to make sure that you're reviewing how that is limited. So it could be by user agent, IP address. That's up to the corporation to figure out, but you don't want to limit by 3,000 for all users. You might want to make it specific to the user that's querying that GraphQL API so that they're not running up, the cost of the queries for this GraphQL. Okay, those are some very common misconfigurations. I specifically labeled these ones because these are the ones we're going to see when we start exploiting our GraphQL API. All right, let's jump into the exploitation. Okay, so before I show you some of these exploits and how they work, I want to break down the structure of what I'm going to do and how I'm going to do it, because it's going to be a lot different from what you might see out in the wild. So I'm going to approach this black box style and vocalize my thoughts. The reason being is in the cybersecurity space, it's so common for people to just run a tool, look at results, and then just keep running tools. It's also common for people to run a tool, look at results, and not know what to do next. It is common for people to run vulnerability scanners and report results. We don't do that here, right? This channel is all about understanding the underlying technology behind various tools that we use, so that when we are using the tool, we know exactly what we're doing and we know exactly the results that we want to get. So things like, identifying the technology stack behind GraphQL, we're not going to use a tool. We're going to do manual enumeration. Things like finding the whether introspection is on. We're not going to use a tool for that. We're going to do manual enumeration. Finding the GraphQL endpoint, we're going to do manual enumeration. A lot of that stuff is going to be manual, right? This is to build a foundation so that you can then start researching on your own, understanding how to think like a hacker, what questions to ask like a hacker, what to look for next, some things that might come to mind, what to do when you're stuck, how to recoup your thoughts, how to critical think. All these things are what we're going to be going through as we go through this exercise. Now, there's going to be two parts, just to let you know off the bat. Part one is going to be a few vulnerabilities that we exploit with the beginner mode for the DBGA lab. And part two is going to be a few more vulnerabilities that are exploited with the DBGA lab. But part two, I'm really going to focus on enabling the expert mode and start black boxing this GraphQL from an expert mode, and how to bypass a lot of these controls as they're implemented, so that you can see how to bypass, but also understand how to mitigate some of these bypasses that are happening. So this video is part one, and there'll be a part two coming out eventually. It'll get there eventually. Okay, let's dive right in. Okay, so the first thing I think I want to do is try to find that GraphQL endpoint. I could use a word list, but I just want to try a few first because it's probably easier to just guess a few. So I'm going to try GraphQL, and I suspect it'll be an error because this is a GET request instead of a post, but who knows? And exactly, so it was an error, must provide string query. So I know that we can do a post, and I want to try introspection, but I think it might be worth trying to figure out what the backend would be for this GraphQL application. So I'm gonna send a post request and try to get some kind of error. So we'll do, actually I'll just paste the URL, paste, and then this could just be regular curl. We'll do post, and then that's fine. The header will be JSON because I'm going to send it in JSON format. And then we'll send. Okay, and for our GraphQL query, I guess we'll do D, and then I'm just going to type in query here. Yeah, and then we're just going to dump the header. So we'll just do dump header dash, just like that. So we can backspace this D and enter. Bad requests, post body sent invalid JSON. So my guess is that it's wanting key value pair. So we'll go in and set key value pair here. So we'll do something like this. So we'll put that in double quotes, and then we'll do something like that. Key value pair and JSON format, and then enter, and perfect. So that's what I was looking for. Some kind of error, because now we can grab information. By the way, you might have heard of a tool called like GraphWolf. and you know that fingerprints GraphQL APIs and returns the backend that it's using. It's pretty much just taking error messages, and the way that it was actually programmed is to familiarize itself with error messages and assign the backend based on the error that's retrieved. So we can do this manually. So syntax error, we'll say syntax error is common. This right here is not as common, so we'll take that, and then we'll just hit it with an in text, and then we'll boom, in text. And so it's only going to show results that are in text for this GraphQL module. I don't want a GitHub error. GraphQL core language test parser.py. So let's take a look at what this is here. So Python. Let's see. Syntax. Let's say what type. Let me check the imports actually. From GraphQL language import. Nope. Import syntax error. Test. No. So it doesn't tell me what type. Do I get to look at? No. All right. So let me go back and let's try a another one. Let's see. Let's do GraphQL 1.6. Oh, Google's gonna try to. It's terrible. Okay, so this didn't necessarily work the way I thought it would, but we'll keep trying. So instead of query, let's put random characters. I guess we can throw something random in here. Okay, so it looks like the second number changes instead of the first. So let's actually change that and see if anything else comes up. Oh, I've seen this before. So threat actors fingerprint your GraphQL APIs. So this is an interesting article because it might give us exactly what we want. 3 types of operations. Yep, right here. So this is, we have keys to mirror syntax error and expected name. Let's do the same against a graphene-based GraphQL Python-based implementation. Now we see the error message a little different. So this is graphene-based Python. So graphene and Python. So what I'm going to do is actually just echo. We'll do API notes, and then we'll just call this I don't know, we'll call this API notes.txt. And then we could just go into it, API notes.txt. And then we could just record it. I usually use like Excel, but this works. So the backend is graphene based. And I want to just make sure I don't forget that, just in case I want to come back to it later. I have a terrible memory. And Python. So graphene based and Python. So I want to quickly just look what graphene based GraphQL is. So let's do graphene based GraphQL. And let's click on this and see. Library for building GraphQL APIs. Its integration includes Django, SQL Academy, and Google. So possible SQL injection is just a thought. Just thinking out loud here. Okay, so we'll say, does it have introspection? We'll say, does graphene use? I'm sure it does by default. Introspection schema. So yeah, it does by default. All right. Another thing I want to add is It has nested queries. Yes. Yes, it does. Okay, so potential DOS there. All right, so let's start with introspection. Maybe we can do that. So I'm actually just gonna Google introspection. We'll do GraphQL introspection cheat sheet, I guess we'll call it. I'm looking for really big. Let's do hack tricks at first. So there is a query that can be used to grab a bunch of information via introspection, and this might be the, yep, looks like this might be it right here. So perfect, full introspection query. I'm going to actually put this into plugin here, Altar, which will help me with sending a post request through the browser. It's like an IDE for the browser operation. That's interesting. So let's send this. Okay, so it did work. Looks like we got, wow, actually quite a bit of information. This is difficult to read, so I'm also going to try to make this pretty. So first I want to download it because why not, right? Copy this. This is something that I want to look at later, so I definitely want to download it. I don't have to redo this step. And then we'll copy that. And then what I want to do is we're just going to move. I think it was introspection query. Yep. And then we're just going to move it to the main folder here. So it can be there. All right. So we'll open Voyager. Maybe Voyager is a good tool that I like that will show me a GUI kind of interface. Yes. So this is Voyager. Just need to see if I can get it to, let's see, change schema. We'll paste display. Interesting. Working. Introspection. Let's paste this right here. This might be the move. Copy it. That way it's formatted differently. Maybe the format is different. Display. No, it's just not gonna want to listen to me. It just doesn't want to listen to me. Okay, that's fine. We don't need it to listen to me anyway. Let's go back to Altor and let's just do this the manual way. So I'm gonna see if there's any queries off the bat that I could query. So if I could find my cursor here, let's just scroll. Okay, so let's see. So name query, it has mutation, and then it has subscription. By the way, subscription is used for like real-time monitoring, which I don't really care about right now. I just query and mutations are nice to know, nice to do. But this is what I want. I want to see what kind of queries they have. So they have paste, and you can paste public. Queries read access. So what else do they have? That's it. They have lists. You can list paste object. They have system update. So that's interesting. We could try that and see. Unfortunately, I have to do it this way because Voyager is not working for me. So, and I'm not going to sit there and troubleshoot that. System update. We'll do. I think you just type system update. Yeah, it looks like autocomplete's on, so that's helpful. System update, and doesn't have any system. Nope. Has no other parameters. So you send a query. And my guess is that it'll update. I should have saved that actually. Now I have to look through this JSON, even inside GraphQL. So, where is this system update? I wonder if I just open this sudo vim. We'll do introspection. It looks even worse. Let's do a JSON beautify. So we'll do JSON beautify. JSON beautify. All right, and then we'll just paste everything. Ah, it looks so beautiful. All right, so now we can look for our. Oh, am I seeing that right? CMD. Yep, nope, that's going to be useful. System diagnostic. Okay, so system update. We'll do no updates available. So that's interesting. So it did try to look for an update. That's interesting. Okay, before I do anything else, actually, I am snooping around, but I'm actually not organized in my brain. So what I want to do is we'll call this attacks maybe, and I guess what I want to do is jot down the attacks that I want to look for as I'm looking through this, as I'm learning how this GraphQL endpoint's working, and what it's looking for. So we know that it has a system update. It has something to do with CMD. I don't know what that is yet, but we'll check that out. What system diagnostic it was. But attacks, let's say DOS. That's like one of the common attacks that we learned. We'll say information disclosure. We'll say because that's CMD, I want to guess that I want to try something like command injection. Code execution, not command injection. Code execution, and then another thing with CMD could be something like server-side request forgery. Server-side. Now these might not work. These are just stuff that I think will be valuable to just try. DDoS information disclosure, and then I do want to check for rate limiting. So maybe we'll say brute forcing. And yeah, that's really it. I think another thing is cost checking. So see if they limit how many queries I run an API. And that's just for like general, best practices, especially when you're doing like bug bounty. So the first thing I want to try to do is DOS actually. So there were two types of DOS. There was the if I can remember, there was a batch, which is just like sending the query in batches, like almost like a list. You just keep iterating through the list and send them in batches. And then there was, if I can remember, there was a nested queries. So those are the two types. We could try it. So what we'll do is this. We'll need to make it almost like a list format, and then open that, and then oops. And then here we'll have to close that, and then something like this. Does this take it? Unexpected. Okay, so it doesn't like this list. So I might actually have to do this in the command line, but that's all right. We'll do this. Okay, and then we basically have to turn this into one line JSON format. So let's see if we can do this. So it's that query, and then this query would end like something like that, and then this would be the query itself would be system update. So system update, and then it would be like that. So let's try to run this and see what happens. Unexpected name system update. So our batch query might not be correct. So let's see. Let's just quickly Google. It's working now? No, still not working. But we'll just quickly Google GraphQL batch query. Batching client GraphQL query. So and it's Apollo, which I think Apollo is very similar to Graphene. So query one variable. So I think I need to do query system update. So something like, with this syntax, it would be maybe we'll say query and then we'll do well, this would be here. Actually, we'll do it like this: query, and we'll do system update. We'll try that. Oh, give it a second. Hopefully that actually works. If not, I'm gonna be a little upset here. All right. While that's doing its thing, I'm actually gonna look through this. So system update, and then there's system diagnostic, and that accepts username, password, CMD, and that's it. Then there's system debug, and then there's system health. System update. Okay, so that actually did work. So we can do a batch. Honestly, we can just copy this. Copy, and then all we have to do actually for a batch is just actually very similar to just doing a an array with like a programming language. You just post a bunch of them inside the brackets and then test if it crashes the GraphQL endpoint. So let's keep pasting. Just keep pasting. Let's keep pasting. Let's keep pasting. Okay, that looks like it's plenty. Let's enter. And let's see what happens to our endpoint. I'm gonna give it a few minutes while I look through more of this. So a lot of system stuff. Okay, let's see what else. Read and burn. Users. And that accepts an ID. User object. Okay, then search. Audits, delete all paste. We need. Okay, so there's actually a lot we can query. So we can actually do what I want to actually look at next is so we just did system update. We can do system diagnostics, and then it accepts username, it accepts password, so we can add these as variables, and it accepts CMD, which is what I'm most interested in. Did we crash it? Okay, so I don't think we crashed it, but my guess is that it's actually running through the batch. So, you know, update not available, then it has to go through this, take the same amount of time, update not available, update not available, update not available, update not available. So we actually found our first bug. What ends up happening is if we've copy and pasted this, let's say 100 times or maybe 1,000 times, we pretty much created a DDoS because it's going to loop through all 1,000, and that's going to take forever. I'm actually gonna kill it. So what I'm gonna do is batch DDoSing does work. So we'll just do works. There we go. There we go. Nice and easy. Now we just got to actually get our endpoint back up. All right, while that's loading, hopefully it gets up relatively soon, and then we can I'm gonna pause it until this gets up. Okay, looks like we are back up. I actually had to skip that. That took a good 10 minutes to come back up. So we're back, ladies and gentlemen. Okay, let's look at what else we can do. So we can look at paste. I know I wanted to take a look at that CMD, but a part of me doesn't want to go out of order when looking at stuff. I like to stay in order just so I can memorize where I left off. So sorry guys, I'm gonna stay in order just for the sake of making sure that I can stay in order and not kind of lose track of where I am. So let's start with paste. And I like to just spend time going through everything. It helps me understand what's happening. There we go. Paste. Oh, do I need to do? Okay, so what does paste have? Public, limit, filter. So public. So we'll type in public, and then I guess we'll send this query and see. Okay, so public false, public false. Let's try limit. So we'll do public, and then under that we'll just type in limit and erase public. Was that not one? Oh, it looks like only public is what I can do. So okay, so we also have paste without the S. So let's try that. Paste without the S, and then let's see what it accepts. It accepts ID, it accepts title, and I apologize guys that this is difficult to read, but hey, that's the best way to do it, right? Jump right in. That's it. ID and title. So let's see. ID. Oh, I thought I saw. Did I see owner? I don't see owner in the response, but autocomplete has owner. So we're gonna go with it. We're gonna go with it. If you see a GraphQL API that has autocomplete, by all means, follow that autocomplete. We don't know what it is. So owner, it looks like owner wants more than one variable. So we'll do this. This will be owner ID. And then I thought I saw title. Yeah, so let's try title. Yep, title works. This is okay, so there's nothing here. Let's see. Paste ID. Okay. Public Boolean. Okay, so paste null. I want to actually try something. So I went a little too fast. I want to make sure I grab the Boolean for paste. Actually, let me just do it this way. Yeah, paste. And then I think this was just public. Yeah, public. And I want to see if I can set this to true and see what happens. True. Connect for true and paste object. So, okay. So, I might have to do it the GraphQL way, which is something like that. And then I think this has to go inside. No, it's Boolean, so it doesn't go in double quotes. Public true. Okay, so then let's send that. It won't work. Bad request. So inside public, what other? Limit int filter string. I don't know what filters there are, so let's do limit. We'll do limit. That's even it. No, so it's not gonna let me use limit. Maybe I can now nest it with paste. Yeah, I might be able to. Let's try to nest it with paste. We'll do paste and then paste. Let's see if it'll allow anything. ID. Yep, it does. Is that in the same? So that's up here. Yeah, so that's interesting. Title. Let's see if it lets us do that. Yep. Paste object. That's it. So let's try this. I remember it was like owner, yeah, owner ID from last time. I guess we don't necessarily need that. Let's just do ID and title and send that query. And we have my first page. What is even testing? We have information disclosure. Okay, so we just learned that paste here, setting this to true, which it's this public value, setting public of type boolean to true, reveals information under the paste query. And we just use ID and title under the paste query. So those are kind of connected in a way. And I wish that it was working with, let me just copy this and try one more time. I wish it was working with Voyager. We'll do GraphQL Voyager because it would have been a lot easier to see, and it would have been a lot easier to kind of make that connection. But yeah, for some reason my Voyager is not working, so we're not even gonna keep worrying about that. Okay, so that's pretty cool, and we learned something new. Paste that boolean, set that to true, and GraphQL will set that to true, and boom, there you go. You have some information disclosure. One of the big things to know about GraphQL is this syntax can get a little wonky, so feel free to go through. This is actually introspection type of syntax, so well, just basic GraphQL queries, I guess. One thing to also note, you can use Burp Suite to go through these things. Burp Suite will convert the JSON to string format, so it's really confusing to read, but there are things like, I think it's called NQL, that can convert it back to JSON. I personally, you know, just like to stick to the bare bones and try to learn. When I'm lazy, I will use Burp Suite, but other than scanning kind of thing, it's really good to get to understand what things are, what it's happening, and even what the scanner is doing. So actually, I'm going to go here. Sometimes scanners do things that we actually could do manually. And it's good to know what the scanner is actually doing. So I'm actually going to say paste, and then I'm going to draw an arrow like that, and then I'm going to say paste. And then I'm going to have ID title. So this is basically just me telling myself that paste draws from paste and it has ID title. And then I'm going to say public equals true. That way I know exactly what query I ran to get this result. And then I'll say something like that, and then we'll say information disclosure. Boom. We actually have not tried nested queries yet, so we're just gonna go straight down the line and keep going. Okay, so next would be our system diagnostics. So let's take a look at what that is showing. So I'm going to just delete this. Okay, perfect. So I'll do system diagnostic. And then I know we saw that CMD, but let's go back and see. So we see username. So let's type in nothing. So system diagnostic, I think, does not accept variables. Username, password. Okay, so it does. Path system diagnostic. Resolve system diagnostic, missing 2 requirements. So we'll do username, maybe. So let's try adding it above the query, and we'll see. We'll do system query system. Oops, I'll fix that. Diagnostics. And can we set a username and password here? Something like this. Let's try it. I don't know. Test and password. Test. We could try sending that. Expected $, phone name, query system, username, test. Okay, so that's good to know. So I think it's looking for that here. Then we could just Google that to figure that out, honestly. Like look at some what I would generally do is just look at some blogs and see if anyone else has had this issue. We'll do that. Expected $. All right, let's see. User ID 5. Okay. It worked if you removed the initial curly bracket. This curly bracket. Okay, so this is that's a little helpful. Do we have a user ID in this? System diagnostic, username, password, CMD. No, so we don't have user ID, but we have username, password, and it's inside. From the other message that we had, it was inside the function, so we know it had to be inside parentheses. So we'll just try it here. Yep, nice. Thanks. Autocomplete, password. I don't know. We'll do admin, and then we'll do. Sorry, I actually should have been username, not password. Username, admin, and then this would be password, and this would be admin, maybe, and then CMD. Oh, CMD works. And then we can do I don't know, we'll do PWD, see what happens. Password incorrect. Okay, so we might be able to actually try to brute force this, but I don't want to. I wonder, should I try to brute force this? That's a question. Or graphene. Let's try doing like something like graphene default password. Graphene. Let's say GraphQL. Email username. True. Is there a default password? I don't know if there's a default password here. Allow login, allow password list and password. Oh, maybe this has it. No, I don't know. I mean, we can always fuzz, so we'll just say password word list top 1 million. We'll say common password word list. I don't know if I want to go through 1 million different passwords. 10K, that sounds more reasonable for a lab. This looks like it's good enough. So what I want to do is we'll do sudo vim, and then we'll just call this passwords.txt. Nice and easy. I could have just copied that another way. So we can actually use fuff for this part. And I think that's what I'm gonna do. Let's copy. So we'll just do fuff w passwords, and then we'll do something like u http, and then we'll just say localhost 5013, and then we'll just do GraphQL. Do we need to specify posts? I don't think so. So we'll do H, and then we can specify content type here. And that's going to be application JSON, and then we can specify the data like this, and then paste. It's going to paste on multiple lines. So we actually, sorry guys, we actually might have to type this out. Query. You know what? Let's just do this. We'll do post requests. Or is there a way to convert this? Copy as curl. Copy curl command to clipboard. So let's paste that somewhere, shall we? Let's paste that. I don't know. Browser's fine. We'll do here. Boom. And that's, yeah, just like that. Copy. And then that will be boom, paste. Perfect. I guess we could specify the variables. We don't necessarily need to. Okay, so the password is what we want. So this would be fuzz. And then we want to ignore comments. And then I guess we want to check status codes. It's all going to be status 200, of course. I wonder if there's going to be a different size though. We can figure that out. Oh, I thought I saw something. 44. Change me. Perfect. We could have at least, by the way, we could just do FS for like file size. I think it's FS like excludes the file size. And then I think we could exclude 51 like that. Yeah, so it should just tell us anything that's not file size 51. And I'm only going file size because everything is showing status 200, which I think is a normal GraphQL thing. So yeah, so it looks like the password's changed me. So if I actually type in change me here, and then send this request, I get the PWD. So actually I can just type in, maybe I can just do something like cat, and then that would be, yep. So this would be command injection here. So nice, we have a full CMD. We could do a lot with this actually. We can do like a reverse shell, and a few more, but we'll do this. Let's stop here, and then let's do sudo vim, and we'll do API notes. Did I not? Sudo vim notes. I had my notes in 2 different files. That's funny. Okay, so code execution. So that works. I'm just gonna write username password. So it was sysdiag, and then user was admin, which was super lucky. We just guessed that. User admin pass change me, and then CMD was I don't know. We can just do anything at that point. Okay, so we know that works. And I think it would have been another bug. So what I'm going to do is I'm going to actually stop here. Now, I want you guys to kind of understand the thought process behind this. Yes, I do know that this is a vulnerable endpoint, and finding these bugs are relatively easy than to find a real world where you have controls. In fact, you know, part 2 or 3 or whatever we go through, I will go into that security lockdown GraphQL endpoint and try to find some bugs for you guys to see, so that in a real world it'll be a little closer. I mean, these things will still show up in the real world, but as easy as we just found it, probably not. But the point of this video I want you guys to understand is the thought process behind exploiting GraphQL endpoints, and also the syntax used. GraphQL has really wonky syntax, but as you can probably see, some of these queries I actually did have to Google. I did not know. Trust me, I did not know. I had to Google. But we got it figured out, and we found just a few bugs. And I'm going to stop here because I think that is a lot of information to ingest. But there will be a GraphQL part 2 where we go over more of the easy, and then there's going to be towards the end of part 2 we start getting into the advanced stuff, and then also part 3 we start also getting to advanced GraphQL exploitation, and we get to do some more Googling for that syntax there. You feel any smarter yet? Are you a better version of yourself at this moment in time? I sure hope so. Seriously, thank you guys for watching this video. This was really fun for me to make because I don't usually make videos where I'm thinking out loud or pretending like I don't know things. And then I actually did stumble upon things that I actually didn't know. You know, I was black boxing a lot of this. Things like the information disclosure, I had no idea that existed. And that was just a fun process. I bet you couldn't tell which part I was faking. You probably couldn't. And don't go back and watch. If you like this video, it would do me a favor if you went ahead and subscribed, liked, commented, and hit that notification bell, because there's going to be more GraphQL videos, and I'm going to be doing a lot more other technology deep dives, and also these exploitation labs where I'm saying my thoughts out loud and completely black boxing it, so you can kind of see the the hacker mindset. But then there's going to be other videos where we deep dive into the technology and start to learn things from the defensive approach. You know, things like applying these security controls. How do we protect against these exploits? Those things are really important. Yeah, so just as important as the offense is, defense is just as important. Also, if you'd like to see a video request on some kind of technology deep dive, whether I know the technology or not, feel free to comment it below. If I don't know the technology, it's my job to research it. So I got you. If I know it well, you can expect a video relatively sooner, sooner than it would take me if I had to research it. But appreciate you guys. Pap out.